You spend 3 full days writing 200 lines of playwright automation code. At 2 a.m., the website changes a single button class from submit to submit-v2. Your entire pipeline crashes instantly with a brutal missing element error. Welcome to The Freshers, where we break down complex tech into simple visual intuition. Traditional web scripts act like a train fixed to rigid steel tracks. If one track switch moves 10 centimeters, the train derails immediately. These brittle selectors force developers to spend 70% of maintenance time repairing scripts. Every front-end layout update breaks the CSS path you carefully hard-coded yesterday. We need an automated driver that actually looks at the screen instead of following blind rails. Instead of writing exact code paths, what if we gave software a human goal? That missing driver is an autonomous browser AI agent built to understand goals. Instead of typing 50 lines of playwright code, you provide plain natural language intent. You simply tell the system, book me the cheapest flight to Delhi under 6,000 rupees. The agent understands the goal and navigates the website like an adaptable human driver. Traditional automation relies on hard-coded CSS selectors and rigid step-by-step instructions. Browser agents use goal-oriented scripting to decide navigation actions dynamically. They read the web page layout, handle unexpected pop-ups, and locate buttons by visual meaning. You specify the desired destination, and the agent operates the vehicle on its own. This shifts web control from mechanical steps to outcome-based decisions. But if AI agents navigate websites using plain text, are tools like Playwright completely dead? Replacing rigid scripts with dynamic goals leaves a gap. How does an AI perceive web screens and plan its next moves? The agent uses a vision language model to inspect screenshots visually. This multimodal brain acts like a driver looking through windshields at street signs. To save token costs, the browser converts raw HTML into a simplified accessibility tree. This strips DOM clutter and cuts token size by 80%. The planning engine evaluates visual context to calculate each next micro-action step. It generates a structured thought chain that determines whether to click, type, or scroll. Instead of searching invisible element paths, the AI targets visible screen controls. It works like a live GPS recalculating routes whenever new web pages render. Each decision brings the agent closer to completing the goal. Planning the next move is only half the battle. The driver still needs physical steering controls to operate the vehicle. The browser control layer translates AI decisions into real mouse clicks using Chrome DevTools protocol. Frameworks like Browser Use or Stagehand dispatch these native events directly into headless Chrome. When a surprise promotional pop-up blocks the screen, a rigid script crashes instantly. The agent's memory and reflection system captures a post-action screenshot to check if the click succeeded. Noticing the blocked view, the planning loop inserts a detour action to close the modal first. This dynamic self-healing capability allows scripts to survive total website redesigns without human intervention. The agent checks its rearview mirror, corrects mistakes, and finishes the trip smoothly. Self-correction turns fragile web automation into a resilient software engine. Self-healing code is impressive, but the real test is applying it across support, finance, and CRM workflows without building APIs. Browser agents turn every unintegrated website into an instant universal software API without requiring developer access. In customer support, agents process customer refunds across 15-year-old legacy portals in 30 seconds. Finance teams use them to log into vendor dashboards and reconcile PDF invoices automatically. Sales teams enrich lead profiles by pulling data across corporate directories. In software testing, QA engineers write end-to-end tests in plain English that never break after front-end deployments. Everyday productivity transforms when an agent searches multiple travel sites to prepare flight checkout forms. If a human can navigate a visual website, an AI agent can automate it. eliminating hundreds of manual clicking hours. Turning every website into an API has sparked a massive rush across major model providers and open source startups. The open source framework browser use exploded to over 90,000 GitHub stars in just a few months. Startups like Stagehand, Skyvern, and Steel.dev are building specialized headless browser infrastructure for AI agents. Model creators are pushing computer control directly into LLM engines. Anthropic introduced computer use in Claude 3.5 Sonnet to calculate pixel coordinates for mouse clicks. OpenAI built Operator to run web navigation tasks autonomously inside browser sessions. Developers connect these open source frameworks to existing LLMs to deploy autonomous web fleets. Google is integrating Gemini agent capabilities directly into Chrome execution environments. Web automation is rapidly evolving into a standardized agent software stack. Rapid ecosystem growth obscures major trade-offs: multi-second reasoning delays, LLM token costs, and security risks on live checkout forms. Every AI reasoning step requires a multimodal inference call, making agents significantly slower than microsecond playwright scripts. Processing high-resolution screenshots and long accessibility trees accumulates recurring API token costs on every single run. Multi-step workflows risk compounding early errors into late-stage task failure. Modern anti-bot platforms like Cloudflare Turnstile actively detect automated browser drivers and block agent access. Security guardrails are essential because autonomous agents can trigger irreversible credit card payments or data leaks. Prompt injection vulnerabilities allow malicious web page text to hijack internal instruction chains. Responsible deployments implement human-in-the-loop triggers before final payment authorization screens. Understanding these operational limits prevents expensive production failures. Earlier, we saw how fragile scripts crash on renamed button selectors, raising the question if Playwright is dead. The short answer is absolutely not. Deterministic scripts are not dying. They are becoming the mechanical hands for AI brains. The future of web automation is a hybrid architecture that combines raw speed with agentic flexibility. High-speed Playwright code handles predictable login screens and static form fills in sub-millisecond time. When the script encounters a dynamic layout change or an unexpected pop-up, it hands control to an AI agent. The AI uses vision and planning loops to resolve the obstacle before returning control to the script. Frameworks like Stagehand implement this hybrid pattern using simple act and extract primitives. You get classic script speed alongside self-healing artificial intelligence. We are witnessing the transformation of the entire visual web into a universal software interface. Millions of human-facing websites are now instantly actionable by AI without waiting for official API integrations. Developers who want to build next-generation automation must master tool calling, Chrome DevTools protocol, and agent planning loops. Browser control protocols turn language model outputs into precise mouse movements and keyboard inputs. Understanding memory systems and reflection loops ensures your agents recover cleanly from runtime errors. Learning how vision language models process accessibility trees enables you to build self-healing enterprise automation suites. Combining deterministic Playwright scripts with adaptive AI drivers gives you the ultimate web automation toolkit. That is all for today's deep breakdown. Like, follow, and subscribe to The Freshers for more tech guides, and comment below what you want to learn next.